Welcome to some more Lab Rat Fun Networking with Fish. This is the second in the Show and Tell BGP series, and at the end of the last one, and I'm really too lazy to go fix it, at the end of the last one I said that we were actually going to do an eBGP peer between R3, and I erroneously said R40, that we were going to do eBGP between R3 and this router here, but actually I changed my mind, so we're not going to do that. What we're going to do instead is R2 actually already has the IPv4 address and the IPv6 address. So actually what we're going to go ahead and do in this little BGP show and tell snippet is we're going to go ahead and actually do this. So we're going to iBGP between R2 and R3. Ultimately, we want, again, for R3 to actually have 40, 100, 100.40 in its show IP route. So first it will get it in the BGP table, and then after it's in the BGP table, we want to make sure that 40, 100, 140 actually gets into the RIB or the show IP route table for R3. And then also the IPv6 prefix, because we're also going to IPv6 iBGP peer between R2 and R3, that this IPv6 prefix not only makes it into the BGP table here in R3, but again also into the show IP route or the RIB for IPv6. And then we'll be done with this snippet. So what we're going to do first is we're going to go ahead and go to R2 and R3, and we're going to have them iBGP peer with each other. So let's go to R2 first. So if we go to R2, show run, begin, router, BGP. Again, I haven't actually typed anything or done anything since the last little YouTube snippet, so this is the same as it was before. R2 is just eBGP peered with R20 in Autonomous System 20, both via IPv4 as well as IPv6. So now what we're going to go ahead and do is we're going to go ahead and between R2 and R3, we're going to go ahead and do a router, BGP 10. And we'll do a neighbor. And R2 loopback address is 10.100.100.2. R3's is 10.100.100.3. And with iBGP, it is very common that you actually peer with each other via the loopbacks. So we're going to go ahead and do a 10.100.100.3 remote autonomous system 10. And then we're going to go ahead and say update source, loopback 0. And again, I'm going to go ahead, and this should actually have already happened, but we'll do a activate. And for grins and giggles, we'll go ahead and do a send community. So let's go ahead and do that. So show IP BGP summary. So we're actually iBGP peered, so we are Autonomous System 10. We're peering with Autonomous System 10. We did not have to actually say we are iBGP or eBGP. The code can figure it out. We're actually going between the same two autonomous systems, so we are internal BGP or iBGP. We're not up, but we also know why, because R3 has not been configured yet, so we'll go ahead and say router BGP 10, and remember, I do like to have that router ID, 10.100.100.3, BGP log neighbor changes, I also like that. We're going to go ahead and do a 10.100.100.2 remote autonomous system, point 2, R2 is 10, again, update source, loopback 0, address family IPv4. Now, you don't have to do this. I just like to control all of this. And I do want to do a send community extended. IPv4 would have been on by default. So let's go ahead and do a show right mem. Let's go back over to R2. We're going to do a show IP BGP summary. And we're going to see that we are learning. We are peered. We are up and running and peered. And we are learning nothing from that. Let's go ahead and go over to here, show IP BGP summary. We are learning 3 prefixes. Why are we learning 3 prefixes? Because R2 is actually learning 3 prefixes. So R2 right here is actually learning 3 prefixes from its eBGP peer R20. So it is then going to go ahead and take the eBGP prefixes that it learned that are in its BGP table and advertise them to R3. So if we actually do this and go over here, so show IP BGP, it's kind of strange because what you're going to see is if we do a show IP route, there's nothing in here. Show IP route BGP. There's nothing in here. R3 has no BGP learned routes in its routing table. As you can see, there is nothing. I got OSPF, I got connected, I've got local, as opposed to R2. If we do a show IP route, hit enter, we'll see all of the different BGPs in here. In fact, we have 3 of them, 1, 2, 3, which is all 3 of them. You can also do a show IP route BGP, and we will see these prefixes. The other interesting thing is if you do a show IP BGP, router 2 has this little greater than symbol. See this greater than symbol? So BGP can actually have multiple paths that on how to get to something, and this greater than symbol says these are the ones that my BGP best path decision-making algorithm picked, and these are the ones that are going to get promoted into the RIB. Now I only have 3 paths, but they're all getting promoted into the RIB. So if we actually go ahead and come here, I actually have Cisco Live. I actually have a BGP stick and then reference. So this is the BGP best path decision-making algorithm. And if we actually go back down, you'll actually see that this is an older one. But it actually says before we even get to weight, right, because this is the best path decision-making algorithm, prefer the highest weight. But look, there is stuff up here, okay? There is stuff up here that is before how this works. And for that, I want you to see this. Paths for which the next hop is inaccessible. What does that mean? It says right here that assume that all paths that a router receives for a particular prefix are arranged in a list. The list is similar to the output. Routers ignore paths in these circumstances. Again, synchronization, not synchronization. This is an older PDF. I was being lazy and just used the one that I already had. So routers are going to ignore this, right? I'm not even going to go into best path for this. So, because I know what's going on here, let's do a show IP BGP. Okay, router 3 has absolutely no greater than symbols. Let's zoom in on one. Let's do a show IP BGP. Let's look at the one that we actually have in question, 40, 100, 140. Inaccessible. Okay, so it is inaccessible. What does that mean? With iBGP, what is actually happening is who is 20.2.20.20? 20.2.20.20 is this IP address. By default, with iBGP, when this router R2 sends the prefixes that it has over to an iBGP peer, it leaves the next hop IP address unchanged. So it leaves it as it is. Router 2 learned about this prefix from 20.2.20.20. So router 2, if we do a show IP BGP, 40.100.100.40, R2 learned about this prefix from R20. So the next hop is actually going to be, as you see right here, this is the next hop. iBGP by default does not change this next hop. So when R2 advertises this prefix over to R3, show IP BGP, actually we can see it right here. So when it advertises it 40.100.100.40, the next hop is left unchanged, which is 20.2.20.20. If we do a show IP route, we can see that 20.2.20 is not in R3's routing table. Okay, it is not in R3's routing table. So we have a couple different choices here. One choice is to go ahead and, since this is our autonomous system and we own R2 and R3 and we own the design, one option is this is a subnet that is connected to our router R2. Because of that, we could advertise this subnet into our autonomous system. And then R3 would actually have 20.2.20. Another thing that we can do is we could go ahead and just change R2 from doing the default behavior of not changing it to changing it. So that's what we're going to go ahead and do. So let's go ahead and go into R2, and we'll do a show run begin router BGP and config T router BGP 10, and we're going to go ahead and go right here. And actually, we're not. This is actually something that is going to be actually a change that we're going to make in the sub address family. So let's go ahead and say we're actually going to do it down here, because I might want to do this for IPv4, but maybe not potentially for something else that I have going on. So let's go ahead and do that. So show IP BGP summary. If we go ahead and do a show run begin router BGP, we'll actually see that we now have next hop self changed. Let's go ahead and go over to R3 and do a show IP BGP. And we're going to go ahead and just do a clear IP BGP star, because I don't feel like I'm lazy. There we go. So show IP BGP. And now you will see that the three prefixes that R3 learns are no longer the IP address. Whoops-a-daisy, wrong one. They are no longer the IP address 20.2.20.20. They are now changed to R2's peer IP address to me, R3. So it is now 10.100.100.2, and you can see that after we've made that change now, all of the prefixes over in R3 have that greater than symbol. So we can now do a show IP route, and we will see the BGPs in there. We can also do the show IP route BGP, and we have the BGP prefixes in there. So wonderful. We now have the IPv4 address 40.100.100.40 up here, over here, over here. Now, if we look at this, we can do a show IP BGP, and we can see 40.100.100.140 originated in Autonomous System 40, and then it went to Autonomous System 20. Now, I'm actually in Autonomous System 10, so it originated in Autonomous System 40, then it neighbored over here, advertised it, and then when it neighbored over here to advertise it, the path was 40, so the prefix that this autonomous system that you originated in is on the far right. So we don't have 10 because we are in 10. We know we're in 10, so we don't add 10. So we're all good there. So now let's go ahead and have R2 and R3 actually IPv6 peer with each other. So let's do a show CDP neighbor. And so if we actually look, if we do a show run interface gigabit 0, 2, and again, what you'll see is that I use the IPv6 documentation address 2001 Dogbaker 8. And then for all of my stuff, I always have the two routers. So this is an IPv6 address that is between router 2 and router 3. And then the last number will always be the router that I'm in. So from that, I know that I can do a router BGP 10, and I can do a neighbor, and I can oh, actually, I don't want to do that. I'm so sorry. I still want to go ahead and do the loopbacks. So sorry about that. I was about to actually interface, show run interface, loopbacks 0. So for this one, again, the documentation IPv6 address 2001 dog baker 8, and then the router that I am. So what we're going to go ahead and do is we're going to go ahead and do router BGP 10. We'll do a neighbor 2001 dog baker 8 colon, I'm going to router 3, so that's 3:3:3. And then the remote autonomous system number is still 10. And we're going to do a update source loopback 0. Now we're going to go ahead and go to Azure Family IPv6. And again, we'll do a activate. And then I want to go ahead and send community. And so we'll go ahead and do that. Now, again, because we're actually doing the loopback, and I didn't talk about this with the IPv4, but if we're doing loopback to loopback, there's no magic here. You must be able to get to the IP, to the loopback address of the other guy. So if we do a show IP, if we do a show IPv6 route, we will actually notice that via OSPF, I am already learning about 3333, which is right down here. So our loopbacks are already being, for IPv4 and IPv6, are already being advertised between each other. So that's, that magic doesn't go away. So now let's go ahead and come over here, router BGP 10. Let's do a neighbor 2001, dog baker 8, and again we're going to router 2 and remote autonomous system 10. We want to do update source loopback 0, address family IPv6. I want to activate this, and I also want to do a send community. So let's go ahead and go back over to here. We'll do a BGP 6S. And again, I'm cheating. So this is a show IP BGP IPv6 unicast summary. So this is my IPv6 addressing. And you can see that my IPv6 peer to router 3 is up. I am learning nothing from it. However, I am learning 2 prefixes from R20. So I, as R2, I'm going to share those 2 prefixes with R3. So let's go ahead and do a, actually we could have done a show IPv6 route BGP. So these are the prefixes, and again, what we're looking for specifically throughout all of this is we're specifically looking for 2001 dog baker 8 40 40 ::40. So that's it right here. 2001 dog baker 8 40 ::40 ::40. So it's there. So now we're going to go ahead and look over here, BGP 6X, and again, this is just because I fat finger. I also have a slightly broken finger right now, so this keeps me from making too many mistakes in front of you all by using aliases. So R3 does see that it has a peer, an IPv6 iBGP peer with router 2. And it has already received and sent messages, table version 1, and we have the state's prefixes received R2. Now, the interesting thing for me is table version 1, so to have table version 1 and prefixes received 2, that already tells me there is a problem because you increment the table version. You actually start at 1 and you increment the table version every time you have a new best path, which means it should not be a surprise to me that neither of those prefixes is being chosen as a best path, which means that neither of those prefixes actually making it into the IPv6 routing table. And so again, neither one of these actually has a greater than symbol on it, okay? Now, the reason is again, because of the fact that our next hop is, so even though we changed next hop on R2 for the IPv4 iBGP peer, we did not change that default on the IPv6. So again, We are getting the prefixes properly from R2, but we are properly getting them without the next hop being changed. So this is still the link between router 2 and router 20 and coming from router 20. So again, we have to come back over here. So let's do a show run begin router BGP. And what you can see is that, again, we did not actually set next hop self down here on this IPv6. So we're going to fix that. Router BGP 10. We're going to do address family IPv6. And then I happen to know that this is the one because it's router 3 that we're looking at. We'll do a next hop self. And then we'll do a clear because I'm lazy. IPBGP, and then we'll do the IPv6, and then we'll do the unicast. And then actually what I should do is I should actually come over here. We'll do it over here. Clear IPv6, BGP, clear IP, BGP. Sorry, I thought that I was actually over on the other one right now. And then I want everyone that has this, so I want to clear them all. So BGP 6X. And so now let's do a BGP. That didn't do what I wanted it to do, did it? Why didn't it do that? Okay, I'm going to be very, very, very lazy. Well, I can't actually shut that down and no shut it. So let's do a clear IP BGP. Let's just clear all the peers because again, I'm feeling lazy. So it's idle. This will actually impact my IPv4 and my IPv6. So there we go with 2. So let's do a, and now we actually have, see how the table version incremented? Before, and we just bounced the pure, right? Before we had received 2 prefixes, but the table version was a 1. That to me is completely off. Because every time we actually change a best path, which also means when we first learn something and we choose it as a best path, the table version should increment. So this is I have learned 2, and I told you the table version originally is a 1. So this went up because of the first one and went up by the second one. So we're at table version 3, which is appropriate. And we are, the next hop now is router 2. Now let's look at something here. If we actually do a BGPS for IPv4, what we'll actually see is the prefixes are 3 and the table version is 4. So the table version, and there is a 3-part blog series on Networking with Fish talking about the table version, but the table version is per address family, okay? We don't mix and match. We have different BGP tables. So the table version is per address family. So the current table version for IPv4 BGP table is table version 4. The current table version for the IPv6 BGP table is table version 3. But let's go ahead and do a show IP6, show IP route 6, and again, aliases. So this is actually a show IPv6 route. Again, I have a slightly broken finger, so we can actually see, just like we were saying, what we wanted to do was we wanted to be able to see in the IPv4 routing table over here, 4100, 140 in the rib, and 2001 Dog Baker 8, 40, 40, 40 in the rib for IPv6. Over to router 3 here, we do a show IP route. We can see that 4100, 140 is in the routing information base, and for R3, and so is the IPv6 counterpart. So we are done with this one, and what we are doing next, and let me just check my notes to make sure that I am telling you correctly this time, is yes, what we are doing next is we are going to eBGP peer between R3 and R30. So that is next in BGP Show and Tell snippet number 3. Hope you had fun in the lab, and I'll catch you on the next one.